Hi guys, my name is Kumar. My group members is Iqmal and Tiva. So today we are going to talk about superposition. So I'll start with the introduction. So what is superposition? So the principle states that adding solution to a linear differential equation result in a new solution that's to the differential equation but for different boundary conditions. So there are two types of superposition that we are going to discuss today. One of it is superposition in time, which is the effect in a single well, which is producing in different rate, which will be briefly explained by my teammate Iqmal. And the other one is superposition in space, which is the effect of multi well, which will be briefly explained by one of my teammate also, which is Diva.
Okay, go. So I will be explaining about superposition in space. Well, as my teammate said just now, superposition should be divided into two, which is superposition in space and superposition in time. So, talking about superposition in space, well, we actually take into account that, let's say, one producing well is in a radius of different surrounding wells. We will be actually accounting all the pressure drop of each of the surrounding well as to a cumulative effect to our producing well. So, by definition, superposition is the summation of all individual parts, as I said earlier, the summation of all individual parts of each of the well. And we actually include only the skin effect of our own well. The application is actually the application we can only use, as in for space, superposition in space, we can only apply it to a drawdown, not for build-up, because this is for different kind of wells, not different time, as in like superposition in time. So okay, then moving on from the basics. We all know about the EI equation. As you can see in the slides, we can actually know the pressure of a well by the function of radius, which is distance, and also time. From the EI function, you can see that the first part, which is well A, is only to be counting the effect of well A, and well B, which is the second part, the second column, is only the pressure drop of well B, and the following is well C and the pressure drop of well C respectively. So in this process, the EI function will be combined for three different wells, but only accounting the initial pressure of well A, but only the pressure drop of well B and C. So notice that the changes in the formula that we use is not RW of how the EI function is supposed to be. We use the R radius of each well, which is RA for well A, RB for well B, and RC for well C. So going for the equation to be applied, you can see in the slides, well, the well A, as you can see in the slides, well A and well B, the radius is denoted as RAB, and for well A to well C is denoted as RAC. So in applying the equation, we will use RAB for accounting the effect of well B towards well A, and RAC to actually account for the effect of well C to well A. And as I said earlier, the skin effect we can only include the effect in well A, which is our own producing well, and not the surrounding well. That's pretty much concludes about the superposition in space, and I hope that I actually made it clear about superposition in space. Thank you very much.
Okay, now I will be covering on the superposition in time. That's a little bit different between in space and in time. For in time, we are more focusing on a single well. Okay, let's go to these slides. Okay, referring to the figure above, the well is producing at Q until time Tp. So what is the importance of Tp? Okay, now the importance of Tp is for on the time. On the time is equal to Tp plus delta T. Okay, as equations are linear, the principle of superposition is used. Okay, but in real life, we will not get any linear equation due to a lot of changes in reservoir properties. Okay, the pressure change due to the combination of previous production period is equal to the superposition of individuals changes due to each production phase. The shut-in pressure at time which is Tp plus delta T is mathematically equivalent to a continuation of the drawdown at rate Q combined with an injection at rate negative Q from time Tp. So semi-log is used where PWS, which is pressure well shut in versus on a time. So negative Q is indicate injection. If we have injection, the negative Q will be downwards. If Q is positive, will be more to draw down. Okay, moving on. Next is superposition for drawdown. Okay, the above figure referring to superposition in time applies for a single well system with varying flow rates. Consider a single well with a production rate schedule. To perform superposition calculation, the single well may be visualized as two wells located at the same point, which one producing at rate Q1 from t equal to 0 to t, and the second, which is known as imaginary well, producing at rate Q2 to Q3 starting from t and continuing from period t minus t1 and will be respectively to Q4 to Q5, and the t will be at t2 minus t3 and so on. So as you can see from this not calculation but based on this equation, we can know the delta P of the reservoir. Thank you. Go.
So, to sum up the presentation, so what we can conclude from the overall presentation that have been presented by my teammates Iqmal and also Diva is that both have their own respective assumption, which is later on will be used in order to calculate the well flowing pressure. So when we talk about the well flowing pressure, both composes two different formulas in order to calculate the well flowing pressure, and both depending on the reservoir boundary and the type of the well. For example, the superposition in time, it composes of one well which is in different rate, followed by superposition in space, which is multi-well, and the boundary is infinite. So in order to calculate the PWF, you have to make sure that the assumptions are right. That's all from us. Thank you.